Hey, how's everyone doing? We're getting started right here. Who's all in the chat? I think Mewbot is awake. I'm going to remake up Mewbot. Mewbot, you need to wake up. We're going to start off with some activity right here and doing some coding. So let me get a new fresh page open for the code. I'm still learning what I'm doing. We're going to open up the code right here and start talking about the activity. But if you're in the chat, feel free to say hello. And yeah, so who all is here? We'll see if anyone in the chat says hey. And let me get the activity going right here and we'll start it up. But thank you so much. People are working hard away. Mewbot is awake, so let's throw out some points. John and Ella and Maria, great to see you here. Let's throw out 100 points. Early to chat right here. Mewbot, Mewbot, you want to give out points? You gonna be a good bot or are you gonna be a bad bot? He does his own things sometimes. He's I don't know. What are your thoughts so far? We got John, we got Abigail. Great to see you here, Abigail. I'm going to get the activity going up right here and let all classes know about this. We want this to be a big help for anyone in any BAS 320 classes. We're going to start going over the activity here in just a second. But what are your thoughts so far with the first activity, with going over it, understanding how to code, and doing it? Which the first one's just kind of basic. We'll go over the activity right here. Let's take a look at it. And then the next one coming up, next one is going to be a little not as basic. We've got the introduction. So I think, does we have all the dates? Need to release these. We have a second activity. And let me think. It says February 4th. So let me not put this due this week. I'm going to make some changes right here. And this is going to be due on Tuesday of next week. Okay. 2 seconds. Tuesday. And let me publish it. Publish. There we go. Okay. So let's start talking about the activity right here. And then we're going to talk about both activities. Activity 0. Activity 0, good to go. So let's put a timestamp right here. Activity 0 is what we're covering at 3 minutes and 30 seconds in. Activity 0. Okay, let's do this. So the thing that I want you to know about the first activity right here, activity 0, is it's meant to be almost a free grade. So not saying it is a free grade, but kind of a free grade. So this is the easy stuff. Now, do you need a calculator for this? Or could you solve this in your head? Who just knows the answer to find the absolute value of negative 28? Just, you could be 201 right now. You could maybe be in high school. You could be in middle school. Who knows? I'd ask my nephew Tolliver if he was here. He'd say, what is absolute value? You got it, Abigail, right there, some points. And so we did it. We actually did this. This is for, we're going to do activity 1 here in a moment because this one's pretty easy. So we're going to do activity 0, then we're going to go to activity 1, and that's where things are going to get interesting. Let's try to make this a little bit more complicated because we know the answer. Let's first assign negative 28 to the object x. So help me out, chat, and this is where we practice and we know how to do stuff. If Brian says assign negative 28 to the object x, how would you code assign negative 28 to the object x? So think you've got an object x, you got negative 28, you just need something to kind of store it into something. So try writing that in the chat right here. How would we store that? There's lots of ways to solve this, but we want to maybe create the object x and assign it the value of negative 28. And good practice. Like the only way you remember these things is practice. Ella right there, 20 points. And I need to go off top, chat. Great job, Ella. And so we see right here, Ella's told us x save into negative 28. And you can see in the global environment and try doing these codes. And if all of a sudden the code's not working, you can't run it, let me know. But we're in an R script right now under the plus R script. And so we've assigned negative 28 to the value of x. So now all we need to do, just tell me the 3 letters for the function. What do we need to do to find the absolute value of negative 28? Because we know the answer to this, but we're just showing we can do it with code. Because we'll have to do stuff like this with code. So how would we find the absolute value of that? I mean, it's 28. We know the answer to that. But how would we find that? Yes, ABS, perfect. Ella, amazing work. I don't know. I'm over there in the chat, I think. ABS, x. And that does the absolute value. Great job, John and Ella right there. This is the practice. It's just like, do we know how to do this? Can we go through? And that'd be 28 right there. Find the sum of the following vector. Now, this right here, the C is a what? We saw this in class 2. C is a what? C, be careful. So what is C? C is some sort of thing that does stuff for us. So C is calling a what? C is a type of what? What does C do for us? It's some sort of, it's like ABS. ABS is something, and C is a something, and we use parentheses for the arguments inside of them. C is a type of this, starts with an F. C and F are both different Watsons. So these things have arguments. This one finds the absolute value of X. Functions, John, perfect answer. They're functions. And so C is a function that turns things into a vector. So all this does is just put it into a vector. A vector is things put in order. Now watch this. I'm going to overwrite X. You see X is negative 28, but now X is a numeric vector. That's the class of the vector. That's the elements 1 through 3. So that's just telling you it has positions 1 through 3. And in position 1 is 6, 3, 2. This says positions 1 through 3. So when we look at this right here, we could go and we could just run another simple function on the vector now. And we can say sum of X. And once again, you can check your work. This is why this assignment 0 or activity 0 is meant to be so easy. Because if we say, what's the sum of the vector? Well, you can just add the numbers. It's 11. Find the square root of 38. So we did cover this last class too. The square root of 38 is what? Is there a function we can do the square root of 38 on? I was like copy pasting so I don't get anything wrong. Is there a function? And I'll show you a trick right here you may not know. If you type 3 letters, it'll go to autocomplete. SQRT, exactly. And look at this SQR, and then do this. Kayla, great work too. Try hitting enter after doing this. This is a quick trick right here. After you type 3 letters, just hit enter and it autocompletes. That really helps when you type out longer things like install packages and you can autocomplete. So autocomplete is one of our best friends. Like when I type library, I'll usually do that and it'll make sure it's corrected. So if you were to be typing in square root but had your caps locks on, and as long as you type it correctly, you can click here and it'll correct it. So autocomplete is a huge help on fixing these things. And there's the answer. And we're just going to copy, paste answers. Report to 2 decimals. Sure. Hopefully it has a plus or minus. We didn't round up. Take the absolute value of the elements and then sum them together. Okay, so this is nesting. The idea of nesting is putting a function inside a function. So take the absolute value and then sum them together. So first thing we want to do is put a what around this. Let's make our vector. And you can just call this vector X. We're going to overwrite it. And so we want to take the absolute value, then sum them together. So what should I do to X first? What should I do to X first? What should I do to X first? Oh, add a... Abigail, 50 points. Thank you for asking. Abigail, keep asking. Ask those questions at all points. A hashtag will put a comment, and I'm just storing my vector X right here. So I'm creating my vector X, and then I get the absolute value. And just take a look. I'm running it to view it so I can see the absolute values right there. So there's the absolute values of X. And then once we get this, did it say sum them? There we go. So we've put a function inside of a function. And the big thing to understand here, the learning objective is, it works from the inside out. Like, it's going to take the absolute value of X and then sum it. In truth, we could have done this as like middle steps. We could have said like Y is this, and then go sum of Y, and we get the same answer. So now we did it in 2 steps. Does everyone kind of see the difference where I'm just doing it in 1 step where I say, here's my vector X, take the absolute value of X, and then take the sum of it, because it kind of goes from the inside out. Like the first operation on it is the absolute value of X, because it's the sum of the absolute value of X. So it's going to take the absolute value of X and then sum it. If you reverse it, it'd be the absolute value of the sum of X. So kind of making sure you understand what you're reading right here. It's more about like, what is this code telling me? Take the sum of the absolute value of the vector x. Vector x is stored up there. So what is the sum of the absolute value of that vector? But not so bad, and we should get 100. How did people feel? Have people aced this quiz 0? Have people aced this quiz 0? You should have a 10 out of 10. Shouldn't be that bad. But did people ace this quiz? What are your thoughts? Get that 10 out of 10. Not so bad, right? I hope. This first quiz, not bad. We're gonna go to the next one here. That's where the fun begins. Hopefully no one's freaking out like, oh no. Let's go. Are there any questions on this before I continue? Yep. Good job, Ella, right there. So 20 points. Any questions right now? It all starts out with the basics. Every code is always a little step forward. It's not about jumps. No one's going to have a big jump to where tomorrow they're coding everything. You're going to just have little steps, and it's about asking those questions, like saying, how do I add a comment? Abigail, thank you for asking that again, because after you add your thousands comment, I just think, oh, I want to put a comment. Then I just do hashtag da-da-da-da-da. But the first few times I had to add comments, I was like, how do I add a comment again? So everyone's there. Everyone's asking the questions. But after you do something 1,000 times, you're like, oh, you just do this. And then it just becomes second nature. So let's go towards that. Okay. It is time for activity 1. This is where the real coding adventure begins. So let's jump into activity number 1 right here. And quizzes. Oh, where's activity 1? R basics. Woo, buddy. Get ready. And so what we need to do, let's go to the main screen, is we need to download this RMD file, and we need to download this DAT file. Now, it's very important to know this, that the RMD file stands for R Markdown file. R Markdown. The R is the type of thing we're using, and a Markdown file means it can be knitted. The DAT file is like a brain. It's not just data. Like you would think, oh, actually, this one is, no, it's not, sorry. It is a data file. My brain wasn't ready for that either today. That is just a data file. It's like an Excel file. Frankly, you could open an Excel if you wanted. So that's a customer transaction data file. So let's go ahead and open this. Mine auto associates RMD files. If your file does not open inside of RStudio, make sure here to go to File and go to Open File if you're not opening in RStudio. RStudio looks like this. R is just one page. Don't work inside of R. Whatever you do, don't work inside of R. Make sure you're working in RStudio. It makes life easier. If you want to go hard mode, work inside of just R. That's my suggestion. All this stuff right here, just advice on how to do it all and advice on how things should look. This is question right here. Use the left arrow. So let's put a note right here. Question 1. Right here, question 1 is on 14 minutes. Question 1. So let's do this. Use the left arrow and define x to be 1/2. Confirm the following expressions, evaluate to the given results. So what I did right there is I hit Control-Enter. Control-Enter runs the code. So make sure you have x defined as 1/2, and you can even clear your environment if you want. That removes all that stuff you knew, and run it again to make sure you just see 1/2. And you can see a bunch of comments right here telling you what's going on. So now let's scroll down a little bit, and we have functions written. Now here's the thing. Where am I seeing which thing? Which thing? This is where we're in activity 1 now, and we've defined x as 1/2. Do you see my screen? You don't. Which thing are you looking for? We have x saved as 1/2 right here, and so with x saved as 1/2, that's all we have right now. We just have x saved as 1/2. A bunch of comments right there in the green. I think everything's all right. It should be activity 1. Am I in the wrong thing? This is activity 1 R basics. It should be published now. Go to activity 1 R basics, and you should see activity 1 intro to R. So make sure you open the RMD. The RMD is the R Markdown file. Yep. And so make sure to download this R Markdown file. Yep. So make sure to download this R Markdown file right here. Download this, and then when you open it, you'll be inside of RStudio. You're under the assignments. Yep. I was like, it should be. And then go right here. Now, here's the big thing to know. This is not our code. This is LaTeX writing, or LaTeX, I never know how to say it. This is not our code. You will not be coding like frac x raised to all this stuff right here. The easiest thing to do right now is to click this button. You're now in what's called Markdown Editor, and guess what? The equations look like they should normally look. So what we're going to do right here is we are going to code this so that it solves out to this equation. Now, I don't want you to write the whole thing. All I want you to write right now is I clicked this button right here to go to Markdown Editor to what this is what it looks like when you create the Markdown file. I want you to just write x raised to 1/2. That's all I want you to write. That's all I want you to write. I just want you to code that in the chat right now. Try coding that in the chat. Just try coding x raised to the 1/2. We always code in little bits. So don't code the whole thing. Just do x raised to 1/2. X raised to 1/2 is all I want to see. That's all I need to know how to do to start this. I'm just going to start with that right there. And how do I do that? How do I code that? That's great right there, Ella. X raised to 0.5. That's x raised to 1/2. And you have to be careful because you might, if you notice these come out differently, because that's not x raised to 1/2. That is x raised to 1 divided by 2. And it might work better if you think of it this way, of x raised to 1 and then divide by 2. You can get this to work this way, but you would need to highlight the code and put it in parentheses. And notice now we have the same answer. Does that make sense, Ella? Like, my answer is the same as yours. But Ella, great job. Some more points, Ella. Because Ella, you did it correctly the first time. That's excellent. This will solve to x raised to 1/2. Just make sure whatever you code that you might need to put in parentheses. Hint for the next thing we're going to do. So now we want to divide by something, but try writing the bottom of this with everything Brian needs to add. I need to do x minus 1, but be careful. Be careful. I think funny enough, I think it turns out the same way, but ignore that. But I want to do x squared over x minus 1, not x squared over x minus 1. If you notice the pause right there, I'm trying to tell you the slight difference between what we'd be doing. So what do I need to write on the bottom of this to do over and then the full thing, x minus 1? So think about how to write it. And remember, we're not going to use that LaTeX code. Some people just drag and drop that LaTeX and they're like, is that coding? I'm like, no, you just do it like you're writing a math equation, like in a calculator or something. You're not going to have to do like special fancy parentheses. Yep. That's it. Abigail, great. Abigail. 50 points, Abigail. Perfect answer. Yep. There you go. That's got it. Yep. And then, oh, is it raised to 2? Why did I say, what's wrong with my brain? There we go. Why did I say raised to the 1/2? I don't know. I was asking a trick question or something. Abigail, let's make sure to do that. This is the right answer now. I don't. Ella, 50 points. Why did Brian say 1/2? I don't know. I saw 2 and my brain broke. I was like, why are there 2 answers? Oh, Ella, great answer. So this is the right answer here, and we've done everything properly. Do these spaces matter? No, they don't matter. It's going to solve the same way either way. Just make sure you have it properly written up, and we got it. Now, this one looks super complicated, but I'm going to show you an easy way to solve this. How about we just focus in on writing this? All I want you to do is try writing this right here. All I want you to do is try writing that portion of the code right there. It looks crazy if I show it that way, but I want don't look at this. This is LaTeX writing. We're not doing LaTeX writing. I want you to write that thing up there, but just as an expression. So take a moment. This negative 0.7 plus 1.2x. But write it as a code and be careful. Same answer, even though I have the same thing as you. John, try sending me it. Try I'll put this in the chat, John. Oh, you might not. You might have a different x saved. John, run. That's where I think I got the 1/2 from. Make sure to run that, John, and then tell me what that gets. Try writing right now this in the chat. Just this portion. I'm going to show you a trick. So this right here, try writing the negative 0.7, negative 0.7 plus 1.2x. Be careful. Ah, great. Be careful, Ella. So, Ella, you're super close. You're super close, Ella. And great job on the EXP. So, Ella, really close. This is probably not going to run. It's mad about something. Do you see the catch? 20 points, Ella, and 50 if you get the catch. Run that code I just sent, John, and that'll redefine it. You'll overwrite it. Do you see the one error, Ella? There's one tiny little error. It's right inside of here. Do you see the error? Don't worry. This is what we have to do. Yep. Ella, great job. 50 points. We got it right here. And you know what, Ella? You've actually solved this well enough that watch this. With what you've written right here, and I'll explain the E. I'm just going to go 1 plus, and then I'm just copy pasting. We just did it. All I did was copy paste and did over, and then I made sure to do a parentheses again. Great job, Kayla, there too. Excellent work, Kayla. So does that make sense what you've written right there? Now the expression EXP takes the value of E and raises it to whatever we put in there. It's not raising it to X, so let's just say value. So it's working the same right here. If I could spell. No, I just wanted value. I don't want to autocorrect anything. And if we take EXP, whatever the value is what we're raising it to. So if I do EXP1, that's E raised to the first. Oh, no, no, you could do that. No, that works. This is E raised to the first power. So what is this? This is E raised to the first power. E raised to the first power is what? So the expression EXP takes E and raises it to a power. E raised to the first power would be what? Like value that someone created. E to the first power is, what's 2.71828, 182845904523553. E to the first power is just E, because it's the first power. It's like what is, you tell people, you're like, I know every number to its first power. Should that impress people if you say, I know every number to its first power? Should that impress people? Don't worry, no. It's good to know that. You could say, be like, I know every single number to the first power. Someone will be like, whoa, that's really cool. And you're like, I know, right? Kill 100 points. I mean, you might be able to impress people with it, and they'd be like, that's really impressive that you know every number to the first power. And then if they're a math person, they'll be like, but no, we have to know this concept, and that's why E to the first power is E, but this doesn't know it because there is no value of E inside of R. So we have to use EXP to get the value. It's just, this will raise it. So I just got the answer. We did it. Here we are with a pretty complicated thing. But what way do you think we're going to work on this? I'm giving you a hint right here. What way do you think we'll work on this? This looks complicated, looks like a lot of stuff going on here, but what way do you think we'll work on this? And we're on the Markdown editor right now, if you're wondering. It makes it a little easier to look at. What way do you think we'll work on this? Here's a hint. You can also tell me the first thing to write right here. Inside out, Ella, you got it. So a lot of people would think I should do ln, but there is no function ln. ln is the natural log, which is base E. So there is no ln function. There's no ln function. But log, if you look at log has base exp to the first. That's what base it uses by default. It like 0.4, I'll go and look at it a second here. John, great question. I think 0.47 something. So wait a minute. This says the function log uses base E, and the natural log is base E. So guess what? Log of this is the natural log. That is the natural log of the number. Does that make sense that log of X is natural log of X? So, and John, the answer was this right here for that one. Great job, Kayla. Thank you for helping out right there. I'll show you a trick on this, make it interesting too. What do we need to do next to it now? Now that we've done the natural log of this, what do you think I should put around it next? We're just going to build it outward here. What do you think I should put around it next? What should I put around it next that we just took the natural log of this? So we just took the natural log. We just did this portion right here, but we coded it down here. It's log. We go ABS. So we ABS it. And then we run our code. Run your code each time. And that took the absolute value of it. And then here's the interesting thing. There's a few ways to do this last one. But does anyone know the function? Great job right there. Ella and Kayla and John. And so there's two ways to do this. What are the two ways to do this? Who can think of one way? We now have to do a log 10 on this. So there's actually, interestingly enough, in base R, because we use a lot of what's called the base function, Ella's got it right there, log 10 right here. But you could have also, and great job, Ella, you could have also said log and then went outside of here and said base equals 10. And so that's the same answer because now this log, you're taking the log of this using base 10. So WS, and make sure you do log 10. You can change the base of the log though, but watch something crazy here. I'm gonna show you something ridiculous. So log of x ln. You want to see something interesting? Watch this. Why did this work? This is not what she said. Oh, this right here is not how I would suggest doing it. This is probably really bad coding. But Brian just made a custom function and he named his custom function what? ln. This won't work for you because you don't have the, unless you create the custom function, which I would not suggest doing this because people are not going to have your custom functions. Like if I'm like, oh, I just run ln on it. Someone's like, ln's not in R. And you're like, well, I made a custom function that does it for me. So I made my own function that just does log since log is base E. And then I called it ln. Like I stored into ln the function that takes x and it runs on x the log of x. If I'm going to make it look a little bit nicer, I'm going to say it returns it. This returns the log of x. And then I can run it and it does that. I would not suggest doing this. This best way to do. That's the best way. You don't want to be like Brian at all times. But it's just that we can do neat things like this where we can make our own custom functions where we can just say, well, I have an ln function. It just takes the natural log for me. So I don't have to worry about like, oh, base this, whatever. I just say, oh, there's my ln function. Depends on what you want to use it for. Maybe that would help somebody. Okay, it's time. Are there any questions about mathematics in R and understanding how to write these? And is there a best way? I don't know. Maybe, maybe not. There's ways that are kind of good. And truthfully, my bottom way right here is probably a way that would not be the best because I'm creating a non-base R function. Base R means the functions that you have where you don't have to add packages. These are called base. So everybody has these. They're at the base level. Someone has R, they have these functions right here. So if you install R, you have the base functions. But if you have more advanced things like I've been doing, you'll have like ggplot2, and those are the libraries. So if you type ggplot right now, it's probably not going to show up because you don't have ggplot installed. Just a quick, interesting thing on that. But someone won't have my custom function because they didn't create it. So now on to question 2. How's everyone doing? What thoughts are there? Let's take a timestamp right here. How is everyone doing? That was really great work on question 1 right here. And I want to say a huge thank you for being here. Like, it all depends. Like, I understand people are busy, but I so much love having people here to answer questions. It's so much fun, and I think it's a great way to learn. And I know people use these later, so these videos actually get a lot of views, or they did last semester. So I'm always happy to have people here live, though, because I get to interact. I get to talk to people. Question number 2 is dealing with loading in that data. So we are going to bring in this file using read CSV. Read CSV is a function. Now watch out, because why is this not running? Why did this not run? Here, we'll go out of the Markdown editor. And why is this not running? It's being really weird. Why is it not running? Someone says, Brian, it's not running. We should probably read this stuff right here. Probably tells us what to do. Why is that not running? Why is that code not running there? Why is it not evaluating anything right now? There's your hint. Why is that code not evaluating? Let's see what class says. That code is not running. Look at it's a different color. Well, so it's a different color. I'll give you a hint. If I run this chunk, if I go like ABS of -2. So those codes run, but this code isn't doing anything. You're right. I mean, you're right. It's not a code. I agree with that. It's a what right now. Keep going. So like, oh, that's not a code. That's a what. Really good and good practice right here. It's a comment. Boom. Kayla right there and Ella. Great work. It's a comment. It's a comment. So we need to uncomment it. So we need to uncomment it and then run it. Make sure you have this file. If it has anything like cust1 or something like that, like sometimes people might have like this after it, maybe you've downloaded it a few times. Make sure this is in your files directory. A lot of people have trouble loading up files. You need to make sure your RMD, let me put a note right here. 1, put a comment. Check file name. Does it have numbers? Needs to be exact match. 2, file is in working directory. Oh, I would come up, but I would give it away. Oh, Terry. Some points for Terry showed over here. File is in the working directory. And 3, so good to see you, Terry. And 3, your data file. Your working directory is where you are working out of. So if you type here working directory, what is the working directory? It's get working directory. Get working directory. There I am. I'm working out of my downloads. I'm a bad influence on people. I'm in my downloads. That way, when I download stuff, it just goes straight to my working directory, and my downloads file is just or my downloads folder is crazy. So you want to make sure you're putting. The problem is a lot of people think, oh, I'll make subfolders for each assignment, but then you would want to set your working directory to that new subfolder. This is the directory I'm working in. So what goes here? All my whats. This is the directory Brian is working in. So Brian needs to put what in his working directory? Every single one of his whats, which this is one of those. This file right here, or this is, I'm working out of this. So every single blank needs to go here. I forgot how to do the working directory again. How do I set it? Great question. Thank you, Kayla, for asking that. There are 20 points. Go to Tools, Global Options, Tools, Global Options, and then go right here, every file. Great job, Ella. And go to Browse and then set your working directory here. Since it goes through your computer, I'm doing it. But then click Apply and OK. You might also need to reset R. You might just do a quick reset, like save your files and reset. And then it should load up to your working directory. You can also tell what working directory you're in by going to your files right here. And then you can see the files in your working directory. You can also change it while you're working, but generally, at least for starting out coding, I would suggest having one consistent working directory, and that's where you put all your files and load everything up. And here's the thing, when you run this, what's it going to do? It is going to save into the object cust, the read in CSV file, act1 customertrans.dat. That's the file extension. This is possible to read with CSV, and read CSV just reads CSV files. I bet you can't guess. You've never seen this, but I want you to take a wild guess at what the following function will do. Take a wild guess at what that function does right there. I've restarted our studio. I've used the menu option to change. Yes, nice job, Terry. What do you think read XLS does? Like, what do you think I'd use that function to do? Like, read CSV can read CSVs and DAT files. What do you think the read XLS function from the readxl library does? Now, we don't need that right now, but just take a wild guess at what it does. Any ideas on what a read XLS function would do? Sometimes the function name kind of tells you. What is the difference in quotes and... Oh, good question right there, Kayla. And the read XLS function will read Excel files with extension XLS, or if we have extension XLSX, we can read them in this way. And the difference right here, and this is a very important one, Kayla, thank you for asking this. Let's put a note right here. So to make comments, use a hashtag. This is no longer code that are reads. So when you do a hashtag, that can be anything. Does that make sense? You do a hashtag, you write whatever you want. So, but here's the thing. If we do a quote, we are making, I know you know this, Kayla, because you got this. Or Ella, anyone's got this. When we do quotes, we're actually creating a what right now? What is this? You know, it's just a slightly different shade of green. You can see it really close. We'll zoom in here. What is that thing we've created? Slightly different in color. Oh, and I see, and the quote is an actual word in the code. Exactly. That is a string or a character, characters. It's going to look for that file name. It's saying this is a file name. It's not a comment. It's a very similar shade of green, and it's a character. So you can find out what this is by saying, what class are you? I don't think you can do class on a comment. It says that's characters. So it says R sees that as words, a character string right there. And that's an object that could be saved. Like we could call this object X, and object X is now the phrase, what is this? Does that make sense? We can take that and manipulate that object. And so the comments are not code though. So I've never tried this. I don't think it'll do anything. It didn't really like it. I don't think it saved anything. Oh, it actually ran through. It's reading through to the next line. That's just a bad idea right there. Like it didn't do what I wanted. It appended code right here and it read through to the next line. So it probably would be a better, yeah, it's just a bad idea. Don't do it. This is a word and these are comments. Comments are just like you adding things to your code, and then strings are like actual phrases that you're telling the computer. So this was communicated to the computer, get this file and read it in and store it into customer. Okay, we're not going to do read Excel. Just tell them what it does. Show row 27. Now we get to some interesting stuff right here. Now that we've read in our file, let's do this. Let's run all chunks above. So that runs everything above. You've got that button right there, runs everything above. And so let's show row 27. The customer data frame can be viewed the following way. Now, I do want to show you something here. By running the full thing, what do you think I'll have for 50 points? Something I'll put in my... If I turn this in, I'd have what output? And you'll lose points on your assignment. You might even get a 0. If you were to turn in your RMD file or turn in your knitted file, what do you think you might have? We would say to you if you did this. So here's the document someone turns into me. What do you think someone's going to have? What would we call this when you get your grade? Be like, no, can't turn this into the boss. Excessive, right there. Great answer right there, Ella. It's going to be excessive. But what did we just learn right here? Cust lets us see the customer data frame, right? So here's the customer data frame. And you'll notice it looks like an Excel spreadsheet. An Excel spreadsheet has how many dimensions to it? An Excel spreadsheet has how many dimensions to it? How many dimensions? We've got like the row space and the column space. How many dimensions does an Excel spreadsheet have? How many dimensions got the row space, the rows, like row 1, row 2, and the columns, column 1, column 2, column 3 with names? It got 2 dimensions, exactly. So here's what we can do. We can put in square brackets. This is a huge note. Whenever we do positions, take a big note on this, like we're going to use this all the time. Square brackets are for positions. That is a big note. Parentheses are for functions. So how do you know this is a function? Why do you know read CSV is a function? Put in the chat. Read CSV is a function. I just want to see those. Read CSV is a function because it has what? That's telling you the inside of that is a function. This is what we need to know. If we see those, that's a function right there, and those are the arguments. It's saying read this. Great job, Kayla, right there. That's the function with the parentheses. And then this means I'm going into positions in this. So since this is two-dimensional, I have to separate the positions. Now, those aren't really arguments. Great job right there, John. These are going to be the positions in the customer data frame. Now, if you remember SpongeBob famously said, I want to rock. So I remember rock because rock is the way I first taught myself to always remember it's rows and then columns. Just remember, I want to rock. Rows, columns. Just keeps it in order each time. So I used to teach it when I taught Math 123. I was like, I want to rock. Because it's so easy to mix up. But I've never mixed it up since I came up with that little thing. And so with us remembering rows, then columns, you would, I know, right? So with us wanting row 27, tell me what to do right here. This won't run because that won't run. You know what? I could make it run. Who has an idea? Tell me what to change. It's got problems right now. I want row 27. We'll see what people say. I want row 27. I want all of row 27. Ella, Ella, that's 100 points. Great job, Ella. We're throwing out crazy points during these. Ella said this and this right here, and that's row 27. Interestingly enough, we could probably do it in some really weird ways right here. Like we could say row equals 27, column equals blank vector. And so this would be equivalent to Ella's code, I believe. And we can show, ooh, it's mad about that. It's mad about that C. Oh, I didn't do a capital C. Oh, good. Oh, he's mad. There we go. Yeah, I don't know if the C can... Unless I go null. No. Null? But not still. I don't know if you can do it that way. Yep. It doesn't like it when I do it this way. It says no columns. So you could store row 27. I would not suggest this way, but R is 27. Great job. Love the positivity here. So this gets all of 27. What does the following... If I leave both things blank, what does the following do? Leaving both things blank would do what? It would just display for me what of the data frame. 3-letter word. Just leaving it blank, because remember how we got all the columns here? So if I leave this blank and this blank, this would do what? Since I left them blank, it just gets what rows and what columns. Think of a 3-letter word. If I leave one of those spaces blank, it just says, oh, they must want this of those. Gets all of them. You got it, Kayla. It gets all of them. Brian has just returned what's right here. I'm going to make it smaller so we can see a little bit better. Explain to me, someone said, return to me the data on what? So what did my code do? Someone said, we need information on this. The first blah, 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 blah. I don't want to say it all, though. Think about, like the boss says, hey, we need data on this. And I say, okay, I'll get it for you. So what does this do right here? This gets the data on the what? Because now I've created a vector right here of the numbers 1 through 5. So this would be from our customer data. Rows 1 through 5 exactly. So that returns data on rows 1 through 5. Maybe they only want the vector of amount or the space. Ooh, where's my insert? That's down there. I didn't even know that. And they also want the industry. So now we only returned those values. You can call the numbers of those columns, or you can call the so we could, is that the third, second, and the fifth? No. You can call them by numbers, or you could call them by the name of the column. So all this good stuff right here, you can just say return column 5 or return column with name industry. I didn't even know this for quite a while, but we're in the row space or the column space, and it can help people out sometimes if you space it out. I'm not saying you should do this, but do spaces matter? Rock knows. It doesn't matter. Spaces never matter inside of R. So this is the row space. This is the column space. Return rows 1 through 5 and return only the columns industry and amount. So yeah, you can reorder stuff with this too. It's really nice. What is the column name and number that contains the customer zip code? So now we want to find the column name and number. You know what's interesting? You don't need code for this. Zip code is the what column. Customer zip code. Customer zip code is the what column. I'll show you how to code it here as we talk about this, and you just view it. So customer zip. Oh, I'm showing you this. Yeah, we'll do it this way. We'll go names. There's the names. Customer zip code is the what? Now, it's not the first. It's the 6th. So names, the function names, gives you the names of the columns. Does that make sense? Names gives you the names of the columns. So names takes a data frame and gives you the names of the columns. You could also go call names. I actually usually use call names. Gives you the column names. So it kind of makes sense. Column names, right? There's also row names too. So what are the names of the columns in the data frame? And you can see that czip, and if you count 1, 2, 3, 4, 5, 6, is in position 6. And now that I have this output, I'm getting the what in this vector. Brian has now gotten the what in this vector. What 6? I'm saying go to what, and think of the P word again that we just talked about. Square brackets means Brian's going to what 6? You could say element. I like to say this. Like I usually think about it as like putting things in a row and telling me the position exactly right there. And someone might say, but this is like 2-dimensional. That's dimension 1, that's dimension 2. No. The screen's just wrapping around. It's going to look crazy for a moment. Oh, we almost got it. Can you see it? It's a little tiny. If we could, this vector of names has how many dimensions to it? The vector of names, I had to zoom out really far. I know it's just tiny, tiny, tiny. It's just in a line. The vector of names is what dimensional? It's just because the screen has to wrap it because it doesn't have enough room to go forever out. But the vector of names has how many dimensions to it? And this is like how it actually exists as a vector that it doesn't wrap. It has one dimension. So there's not rows and columns to this. It's just what is the first name, what is the second name. And it might be easier if you think about it by just viewing up here at the top window. It's just one dimensional. What is the first, second, third, fourth? You're not going on a second dimension like on a data frame. You're saying what are the names in order by which they appear. And the only reason it might look two-dimensional to some people is because the screen has to wrap around if it doesn't have enough space. So we're saying what is the sixth name? And that confirms right here the sixth name, right here, position 6 in the vector, is czip. So the name is czip, and it's in position 6, as confirmed by viewing it visually. There's position 6, and it tells you the position right here at the start. Like this is position 7, so before it would be position 6 right there. Yeah. Using either summary or table, find out how many times this person, which person, what person? Find out how many times this person purchased something on the internet. Are we talking about person? I think row 27. How many times this person? So use a summary or table. Oh, wait, no, it's for everybody. Find out how many times this person purchased on the internet. Okay. So now we're looking at not industry, are we? I think we're doing industry. So let me check it out. Cust and $sign. We'll talk about that here in a second. Oh, it's internet? Oh, there we go. Yeah. My brain's not working. Ooh, it's a character vector? Oh, that makes it tricky. Okay. This is why this question is tougher. Characters are what's inside of R. Characters are what's inside of R. I think it could be done this way. Characters are what's. They're just words. These are the variable types up here of the data set we're working with. Integer is quantitative. For 100 points, we want this to be a what right now. We don't want this to be a character. For 100 points, we want it to be categorical. And review from last class, categorical means it should be a what. We don't want this to be a character. We want it to be a what inside of R. So we don't want it to be a character. We want it to be a what for 100 points. Not a character. We want it to be a categorical variable. And categorical variables are known as this. Very important. We're about to change its variable type. A factor. John, that's 100 points right there. John, you're totally right. So let's go around here and say factor. And then let's overwrite what we have. I'm going to drop this code in the chat for you. And I'm going to explain what this code does. You always want to be able to read these things. Kind of ones and zeros. And watch what happens. Watch right here under internet. And watch, ready? Now it's a factor with 2 levels. So what did I say? I said go to the customer data frame and go to the variable internet inside of it, change it to a factor, and then overwrite customer data frame variable internet. The variable internet inside of cust data frame, overwrite that variable with the factor of this right here. Does that make sense? The way you get inside of a data frame is with a what. The way you get to the variables inside of a data frame is using a what. Put it in the chat to remember. We just have to always be typing and remember these things. To get inside of a data frame, you always put a what. So if you're like, I need to get inside this data frame, I've got a data frame, I type the name of the data frame, and then I type a what to get inside of it. So you go here, you go data frame name, type it correctly, and then you go $, and then it auto-completes. Great autocomplete right there. Great job, John, right there. So we go to the $, and we now have the variables. So once again, this would just give us a vector, and this is one-dimensional here. It's just wrapping around the screen, just a lot of values. So this is giving us the values inside of amount right here, which we're not using. But now that we've overwritten this, let's just take this right here and do a summary of the variable. How many internet purchases were there? Well, that's the answer. You have to watch out, though, because there's other ones that are currently strings. And if you were to take something like industry, if you notice, it doesn't report it. But I do think, however, if we make a table of it, I think it's smart enough to report it. So interestingly enough, you could have done this with a table, and it would have actually converted it to a factor for you. So even if we go back here and pretend we didn't change this, I think it would have worked with a table right there. But if we didn't change it, summary would act differently because we don't have class factor. So Ella, great question right here. So the reason is, and this is, so I'll explain it. No, and don't worry, I want to answer questions because great question. I want to answer fully. The way functions work on something in R depends on the class. Because, and I changed it back to what it was, because it's currently class character, when I run summary, it doesn't give me a table. Does that make sense? So because it's character class, this doesn't do what I want because it treats it like a character. But if I change it, so you see currently running this gives you that. But if I change it to a factor, so this is overwriting it as a factor, now it's a factor up here. And when I run summary on it, it reports basically a table. I could have just ran the table on it to start and it would have given the same answer. But the way in which many functions work on things in R depends on the class of the object. Does that make sense, Ella? So changing it to a factor makes it work better with what we're going to probably use it for. It should be a factor. But you could have ran a table and that would get the same answer. A table, I think, is just going to do a factor conversion for you. Like table forces it to be a factor because table's like, I can't do this with characters. So it forces it. No, good question. This kind of goes to data cleaning and stuff. Like probably a lot of these other ones should be cleaned and changed. Like literally you could just take your code right here and go to industry and convert industry to a factor. And their industry a factor with 62 levels. So now that's better and we could convert the other ones too. Make a bar chart of industry. Would it have worked previously? Would it have worked previously? I'm interested. So to make a bar chart, bar plot of industry. No. Cust. Oh my gosh. Cust industry. Doesn't like it. Why doesn't it like it? Why do you think it currently does not like industry? Why is it probably mad about industry? We could try another way. Oh, it's super mad. It's not happy. What's it probably mad about? What do you think for bar charts? Stat tool one time. Bar charts are for what kind of data? It's up there. Review a stat tool one. I tell my tool one students, I'm like, we use this all the time. Bar charts are for what kind of data? That is the issue. That is the issue, Ella. Yep. It's currently a character and it needs to be a factor. So what are we going to do? Categorical data. We need to make it categorical, right? So let's take the variable right here. You know what we could do? Watch this. Factor of this. You know what we can do? X. Now, you might want to overwrite it in your data frame, but what have I just done? I've created a vector X, which is the a factor from the variable industry in the data frame customer. Does that make sense? Cust. So in the cust data frame, we're taking the variable industry, turning it into a factor, and storing that into X. So what probably can I do right now? Let's cross our fingers. Who knows the next command I'm going to run? Just think of how I'm going to change line 147 right now. What do you think I'll probably do on line 147 right now? Line 147 probably needs to become this. What would you change line 147 to now? This is just another way to do it. There's so many infinite ways to do things. What should we do? Plot X. We've got it stored as X. I think I did capital. There you go. That's got it right there. Now I want to show you, I want to do one quick aside on this because, it's base R and I can't let that slide. Start the clock. You ready? Start a timer. How long? Start a stopwatch. Stopwatch. Here we go. Starting the stopwatch here. I'm going to try to make a really pretty graphic in moments. I'm going to steal code. Not literally steal. But you can make really nice bar charts in moments. So we're going to quickly make a bar chart. Bar charts in R Plotly. Okay, let's see if we can get one right here. Bar charts Plotly. Okay. Yeah. Okay. Well, it's free. Oh, they're making it all crazy. I've used some of these graphics before. Displaying figures. Okay. We'll use this one right here. And cool. XY. Move an XY type bar. Maybe I won't. I'm failing everybody. Not literally. I'm failing you at this. Let's grab this right here. Just a quick aside. Trying to spend more than 3 minutes on this. And there's their code. Can I fix it really quickly? Here's their graphic right here using plot. Can I reorient this quickly to our data? X and Y, and those are the values. That's what they're graphing. Type bar. How do I know if I moved over to R? When I hit file in R, it literally opens it. That should be, if that makes sense. How do I know if my data is moved over to R? When I hit open file in R, it opens. We might need to hop on a Discord, Kayla. I might need to take a look at your screen and see what's going on. I might need to look. So let me know here in a moment, or we might hop on and take a look. That's their data. And they've got an X and a Y. You know what okay, wait. I have an idea. Table. Factor. There's that. Names. X equals this. Let's go X vals. And then, okay, there's the names. And then let's go here to Y values. And then as.numeric. Okay, is that the Y values? There's the Y values. Here's our X values. Here's our Y values. Please work. Didn't crash. There we go. And so here we are. So how quickly were we able to do this? And all it takes, and we didn't change the title, but take a look. We now have an interactive graphic created right here where we can zoom in. And so with this, we did this in 3 minutes, 16 seconds, about 3 minutes. We found code that looked like what we wanted. And now we have an interactive graphic to where we can see the different amounts. So you know what's even better? You can put this on the web. So this is a web-enabled graphic right here using Plotly. Like they've got that. We can change the title pretty quickly on it. But this is an interactive web graphic right here. And we could say like industry, our sales are in. And then if we were to go here to knit the document to HTML, you know what? I'll put this in the 320 chat if you want to check it out. So let me drop it in 320 chat, but take a look. It's right here. So this would be enabled to be web enabled. You could zoom in on it and look at just certain portions of the graphic and just take a look. You can even expand the scale or whatever you want. And you've got an interactive graphic where people could take a look and then hover over and get the answers to what the amounts are. So this is kind of a more advanced way to do graphics and some of the stuff we teach in our later classes, but it's all about practicing. And so if you want, I will grab this code right here. As long as you've got the cust data set loaded in, might require some packages. Probably Plotly and stuff. Yeah, let's say library Plotly, yep. Let me drop this on the Discord, and then we'll finish up here because we're almost done. So John, I'm going to drop this on the Discord. And so let me go to Discord and drop this in for everybody. And fun Plotly graphic to do what we did. Better way to make bar charts. There we go. Okay. To me, I like making good graphics. Like, what do you think looks better? How much better does the graphic look? Your thoughts on this, John? Anyone? Like, you've got this graphic right here or this graphic right here where you can like hover over. So is what I need in my graphic to be Oh no, so you don't turn these in. You just answer the questions about like how many there are. So the point of activities is that you answer the questions in the activity. So if you look at the activity, there's questions. You won't be turning in this file, but still, I highly suggest doing this and practicing. Here's your base R bar chart, and here's a Plotly version of it. So this is the Plotly version, and this is the base R version. So I know, right? And then we were able to create this in about 3 minutes. But that's where your skill sets come in, and there's so many things you can do to this. You can set the themes. There's just endless things you can do with these graphics. Like I'll show you. I literally went and took the code from right here. I found this one that I wanted right here, and we could have done it multitudes of ways. And there's just so many ways to make graphics and so many different things you can make, just depending on like what you want to make with box plots or things like that. There's endless graphics you can make. You can do all the different things like different colors, and also you can like deselect stuff and reselect, and they're all interactive graphics. I'll send you a video of it happening. Yeah, send it. Yep. So all of this right here, you just have to learn what the code means, what it's doing, and then you can make your adjustments and make your code work. Once again, I don't expect you to do what I did, but I posted it in the Discord if you want to take a look. These are all like color codes right here and grid line codes, all that fun stuff. You see the distance, how far someone the customer is from the store is -999 for row 563, a bogus value. Replace this value by the number 2. Use by the number 2. Replace with number 2. Using the left arrow, show row 563 on the screen after this is done by verifying the change. This is done by, okay. So, and it basically shows you how to do this right here with the different ways. The first thing we need to do right here is we need to actually look at the row. So there's a ton of ways, and these are all the different ways to look at it. This uses the data frame, then the vector name, and then the position in the vector. This uses the data frame, the positions in the data frame, the row name, and then the name of the column we're calling. Column distance is what column, like what number column, you could count it. There's a lot of ways to know it. What column number is distance in this data frame? What column number is distance in this data frame? It's the column name is distance, so you can call columns by their name. It's the 10th. Great job, Ella, right there. It's the 10th. So when we do this, we can see, and don't worry about that. That's a graphics error because it's mad at me for this. You can see that it is -999. So all you're going to do now is overwrite it. So we're just going to store into that. So we're going to say go to this value because this is what it currently is. And then we're going to overwrite it with 2. And then we need to show it. Show that row. So to show the row, that's how we can show everything. And you notice now the distance is 2. If we want to look at like a before and after of it, we could run the code up here. It's going to get mad at my window probably because I have that graphic. So this runs all code above. Ooh, cancel. I don't want to, I haven't installed packages on there maybe or something. And then run this code right here. Did it overwrite it? Cool. There's the -999. Now here's where I overwrite my code. And then after overwriting the code, I'm going to show that it's the value. So if you look at the process by which this occurred, and we got a bot here again. Hide user on channel. There we go, fixed. You'll notice right here, we're viewing the row. We're storing over this value right here. And then we're viewing the row again to confirm the change. Always be kind of like careful when you do things like that to make sure it works out properly. There is no undo button in R. That is something huge to mention. There is no undo button. Last 2 questions. Here we go. Make cust D to be a subset of cust where the distance is greater than or equal to 0, selecting only the amount of customers, selecting only the amount and distance customers. Okay. So now we're only going to select the amount and distance columns. Mean of amount of column. Okay. And then find the summary of the distance. Okay, cool. So we're using the subset function right here. And this is usually the tough part for people. Inside of functions, we have what are called arguments. Subset first asks, what are you subsetting? Then we do conditions. Let's do it this way. 2, 2, 2. Okay, cool. What are you subsetting? Conditions. And then we often do select equals da da da. What columns are you selecting? Okay. So when you look at this right here, this is not a function right now because I wrote it as comments. So that's not a function. It's just I wrote out something to see what we're doing. So let me ask you the first thing. What am I taking a subset of? It's mad because of the thing. What am I taking a subset of? What am I taking a subset of? So the first argument is, what are we taking a subset of? This is not meant to be code. I'm just kind of showing you the structure of what we're coding. So we're going to do 3 things here. We're going to give 3 commands to it. We're going to say do this and then do this. Well, that's going to be the columns we're selecting. So those will be the columns we are selecting. So where do those columns come from? What are we where do those columns exist right now? So we're going to subset this data frame. So where's the subset coming from? So like, where's the data coming from? Yes, exactly. So if you run this right now, it has no conditions. So now we're inside of this. You know what's really interesting? There you go. We have now just taking a subset of customers that have distance greater than or equal to 0. Let's go to like a distance greater than or equal to 20. And what do you notice? What do you notice about the rows we're getting down here? As I increase that they need to have a distance greater than or equal to this, what do you notice about the amount of rows we're getting in this subset? As I do this right here, you're noticing what? I'm trying to get down a very small amount. As I do this, you're noticing, oh, did that even print anything? I don't think it did. As I do this right here, it's getting very, very what? I think that is printing, but it's just very few. It's enough that it doesn't do a max print. It's getting smaller, right? It's getting fewer and fewer because I'm saying only the customers that have this, only the customers that have this. So we're doing a smaller and smaller amount. But we only want distance greater than or equal to 0, and that's a subset. If you start changing this right here to say, well, they need to have more than 50, you'll get less rows. And so it does like a max print. Like it only does so much output, and then it says like we omitted this many rows. So it's like, I'm going to stop printing. Let me change via the max print function. So now you could, and this doesn't ask for this, you could say and look how it does a sub indent. Let's say internet equals yes. So these are only customers what? Take a look at the data right here. These are only customers that have a distance what? These customers are only customers who had different distance greater than or equal to 50, and they have internet. This is huge helps for your assignment right here. Notice I put in and not a comma. If I do a comma, I will go to a new what? Notice how it goes back to the original sub indent. I don't know either, Kayla. If I do a new comma, I put in a new what? Keyword right here. By doing a new comma, Brian has gone to another what inside of his function. Every time you do a comma, and this is a mistake I made early on when I would write these, if you do a comma, you're going to a different what when you're programming this. Doing a comma means you're going to a different what inside of it. Starts with an A. You're going to a different argument. Different argument. So if you do another comma, you're saying new argument. We don't need this second thing right here. Section, everything. There we go. So what do we need? Great job right there, Ella. We need another argument. And we go right here. And I don't know, let's go a little down right there. And we go select. And you notice how it auto-completes. Make sure you have the autocomplete working. And then we're going to select a vector of information. We're going to select only the amount. And watch out. These need to be in quotes because it's going to look for the name of that column. And there you go. Does this look, when you run this code, does this look to only select distance greater than or equal to 0? Great job, Kayla. And only the amount and distance columns. So this only selects from the customer data frame. Oh, there we go. distance greater of 0. A distance greater of 0, and then we only are selecting those columns. So we're selecting, someone needs to have a distance greater than or equal to 0, and then we need to only select those columns and from the customer data frame, and we're making a subset. But this just prints it to the screen. What do you think I should write? I'm trying to make the thing, the thing. What do you think we should write to put before this to go? What do you think we should put right here? Because we want to like put this somewhere. So we created it, but we didn't like keep it. I'd prefer to not lose this when I run it. You bet, Kayla, you got it. We need to store it into that. So we're going to store it into that, and there you go. Now it exists. We only lost a few. We lost, you can see the difference between these, that we lost 51 rows. Great job, Ella and Kayla right there. And now we can just run these functions. Mean amount of the column, well, it literally has it right here. Custody, make sure to do the custody amount. There you go right there. Summary of the distance column. And so it doesn't tell us that one, but it's just summary of the distance column right here. And there you go. That's got it. We just run mean of that vector and summary of that vector, and we get the 5-number summary plus the mean. And we're on to the last question. Dun, dun, dun. Optional. Well, of course we're going to do it. So let's put right here question 3. I should put more marks in these. So here we are on the last one. That was a big segment. Activity 1, question 3. Okay. Make a vector y that is a sequence that goes from 8 to 103 in increments of 1.8. So what we're going to call right here is the sequence function. The sequence function, that's pretty bad documentation. The sequence function uses the following arguments. It has arguments like from, oh, it doesn't even autocomplete, how dare you, to, and by. Does this make sense that I can go, is extra credit? I don't know. No, I don't think we have the extra credit on this one, right? We're going to go from and to and by. What do you think I should go from? Like from is your starting point. We need to go from, to, and then by a certain amount. And there's actually more using the function. Yeah, I think Ella literally just wrote it out. Ella's got the whole thing written right here. Just store into y. Literally just, there you go, from, to, by. Now, there's different ways to make sequences. Like you go sequence from equals 8 and by equals 3 and then length equals 10. So that's 10 numbers starting at 8 that go by 3. Does that make sense? Like going up by 3, you could go -3 and go down. And then, so you can do different things right here. So Ella, I'm doing 100 points, Ella. Great work. But the only other argument to understand right here is probably say length. Length is going to be, and I think it's actually length dot out, but it partial matches on that and finds it. But length tells you how many numbers you want in the sequence. We're not going to use that one up there, but does that make sense? Like go from 8, go by -3, like downward, and then make 10 numbers. So these are 10 numbers starting at 8, going by -3. So you're just telling the computer to write this out. And this is very important for things like my Price is Right app. So on the Price is Right app, I actually do something just like this. If you watch the Price is Right, you know about the Showcase Showdown. And think about how you'd have to code the wheel. The wheel on the Price is Right is the numbers 5 to 100 by 5. So there's every number on the wheel of the Price is Right. Whoops. There's every single number 5 to 100 by 5. So I just said go from 5 to 100 by 5, and then I've coded every number so I can create the spins on the Price is Right wheel. So I'm just taking a sequence, and then I've wrapped it inside of a sample, because all this is doing then is just sampling one of those numbers. It's just saying take one of those numbers, and that samples one of the numbers from the sequence. So it's like, okay, here's my sequence of numbers, sample from that one number. And so just kind of wrapping code once again, important to kind of see how we can use these ideas that are kind of basic ideas. So we have right here the sequence we've created, which is just the vector y, which is a vector starting from 8, going to 103 by 1.8. And we can confirm by just highlighting the code and running it that it does what it said. It would stop at 101.6. And so now create the data described, find how many elements are greater than 90. Is there going to be help on assignment 1, or do we swing by office hours, Ella? And I bet you a lot of people will be very happy. Swing by office hours And a lot of people are probably going to be like, yes, ask the questions in office hours. We've already done a little bit. Let's swing by office hours and we can work on some of them. Definitely tomorrow. I've got 2 sets of office hours tomorrow. So swing by and be like, hey, can you explain this problem? I take like the longer time I do here, and then we walk through it, we talk through it. And people, here's the thing, is I have people who get so good at it, they stop coming to office hours. And then other people are like, you didn't work this problem in office hours. I'm like, well, no one asked. So you might start to be so ahead. All you do is ask, yep. If you ask, I'll walk through and I'll explain each problem. You know, we can solve things like pretty quickly, but the goal is that we talk through. That's awesome, Ella. So honored. Like, yeah, officer's been a little slow lately. So I'm like, I was telling my friends, I was like, I hope people come by. I hope people come to office hours. She's like, they'll come by. Don't worry. Start of semester. You're fine. Don't worry about it. Busy office hours are great. So you're more than welcome to come by. Be like, hey, can you talk about this problem? Can you explain this? Can you work this? Can you show this? Yeah. We probably do about 30 to 50% of the assignment in office hours. I don't mind working the problems. I think it's some of the best way to learn, because this one's really complicated at the end. But it basically tells you what to do. It says, use the length function combined with which, how many elements of y are greater than 90? Well, let's just try this. If you just wanted to see if something's greater than 90 and you got a vector y, what would you code? Just don't even go too crazy. Let me just ask you this. I'll write it in a comment. We have y and want to see if things are greater than 90. Just don't go too crazy. Just write something small. Should be about 5 or 6 characters. We have y and we want to see if things are greater than 90. So you could actually kind of tell the answer. Yeah, that's it, Ella. Yep, very small. Go y greater than 90. There we go. Ooh. We get Booleans. We get trues and falses, right? Now, what's really interesting is there's actually one. Can you just tell me the answer looking at this? How many things are greater than 90? You maybe could have told over here. A little easier to see. Can you tell me how many things are greater than 90? See if you can do that right now, because then we'll know the answer and we can check it. Sometimes when the code gets really big and complicated, a lot of times you can't check answers, so you have to trust your coding skills. But at this point, we can check our answer right here and make sure we know the answer when we run code here in a second. And then we'll talk through what the code does. So this creates a logical vector here. This is logical, trues and falses. 7, I think you're right? 1, 2, 3, 4, 5, 6, 7. That's 100 points. And now, something we talked about at the very end of class is that trues and falses are 1s and 0s. Now, it doesn't say we can do this, but we can. If trues and falses are 1s and 0s, think of a 3-letter code that we could use. So we could put this inside of it and just find the what of it. If trues and falses are 1s and 0s, we could just take the what of this. Because they're 1s and 0s. Those are just 1s and 0s. That's how the computer sees them, as 0, 0, 0, 0, 0, 0, 0, 1, 1, 1. This goes back to the beginning. So we could just find the what of this vector. You can use which. It does direct you that way, and I'll show that way here in a second. Think of a 3-letter, because if they're 1s and 0s, and we just do this to the 1s. Sum. And I'll show the other way right here. So that's a way to do it right there. That's a super quick way. You could also find out the percent by taking the mean of the vector. And that's 13%. So there's 13% trues, or 13% of the elements of that vector are greater than 90. So you can find the percent very quickly, or you could find how many very quickly. So the question directs you this way, though. It says to use which. Now, what which does is which returns the positions of the true. This vector has a length of 53. So that's position 53, 52, 51, 50, 49, 48, 47. This is position 47 through 53. So which, and this is a huge note to have, when you run which, it tells you the positions of the true. Can you tell me what will this code return? You understand which and how it works if you understand what this code on line 220 will return. Which returns the positions of the trues, or in this instance, position. Which returns the positions of the true, the things that meet the conditions. Which is a confusing thing. A lot of people are like, what does which do again? It tells you where the trues are, their position. So what will this code on line 220 return? If I run line 220, it's going to evaluate to what value? And then so I'll show you the final answer right here. Line 220 evaluates to what value? 3. Because that's the position of the true. But check this out. How many trues are there would be the length of how many the positions of the trues. Let me just ask you this. How many trues, just look at this vector. How many trues are there inside of here now? Like just, I mean, I didn't change it, but how many trues are there inside of there? So the true is in position 3. That's what the witch told us. It said the position of the true or trues. So it said the true is in position 3, but how many trues are there? There's 1. So the length of this vector right here, this vector right here that we just returned is of length 1. Now this vector right here is the positions of all the trues in the previous vector, but how many elements are there in that vector? What is the length of that vector we just saw? The length of this vector is 7. Does that make sense right there? It's more complicated to do it this way with nesting it because you're like, okay, what is the length of the positions of the trues? Like, 1, you're finding out if things are greater than 90. You're finding where the positions of the trues are, and then you're finding out the length of the true vector. So does that make sense, Ella, right here? If you look at it in steps, the steps are, and I'll show the steps for each one. 1, find out if things are greater than 90. 2, find out where those positions are. Like, that's the positions of those trues. And then how many trues are there? So if you look at it in steps as we build our code outward, yeah, and that's pretty tough. 474 students, if you get that and like, psh, that's easy, then 474 students struggle with it. Just you're building your code outward like we did earlier with like the LN and the ABS and all that, building it outward to be like, okay, I need to find out if something is greater than 90. I need to find the positions, and I need to find out how many positions are there. First semester I taught this, I was like, wait, how do I do this again? And now I'm just like, oh, it's like reading a book. Read the book 1,000 times. You read the book pretty well. With that, I think that's got it. Any other last questions? Let's head back to the main screen. I want to say a huge thank you to everybody. Really good practice right here. So we'll just do closing words. Closing words. What questions do you have, if you have any right now? Really great practice. Really great stuff today. You're welcome, Ella, and thank you for working, practicing. Hopefully everyone had their books out and was practicing their code. I Discorded you. Yes. Video was too big for Discord. Oh, wait. Really? I might send it then. No! I'm going to look, Kayla. I got screenshots here. Oh, I think you're trying to open the DAT file. So you don't want to open the DAT file. You want to run the code that loads the DAT file. So Kayla, do this. Here, Kayla, I'm going to drop some code into the Discord for you. It looks like you're opening the DAT file. You don't want to run that. Run this code right here. That'll read it in. You're opening the DAT file, and it's like viewing a DAT file inside of there. So you want to open R files or RMDs. So it's viewing a data file, which that's not really then code. It's a DAT file format. So, and good question, Cal. Thank you so much. All people halfway through the semester are like, wait, what's this? What's this? So does that make sense right there? So run that code I sent you. I'll show you right here on the screen. So you want to run this code on, should be out on line 90. And what this code will do right here is that will open the file. So this code right here, Kayla, if you look at this one right here, if you hit Control Enter on this code, it should do that and load in the file. Does that make sense, Kayla? So you don't want to open a .dat file because this is not an R or an R Markdown file. It's a data file. It's literally just like an Excel spreadsheet. And so we're loading it in. This kind of like reads it in. Like this tells your computer to open it and store it inside of RStudio to the object cust. And does that make sense right there, Kayla? Let me know if that worked out. But the line of code should work right there. We'll see if it works. Hopefully. Go back over to the Discord, and off here with some music. Should do it. Okay, I'm gonna meet with. That's awesome. Well, with that, Puppet Shark, you ready to go, man? These barrels ready to go. We'll be back here later. Check out the interview tonight. I'm excited. Gotta remember to invite everyone. With that, I'll see everyone later. Bye for now. Hey, Hey, Shreya, good to see you here. Awesome. Check out the video. 100 points. Swinging by. Check out the video later tonight and enjoy.